It's Nima from Starting Mathematics, and in this video we're going to be going over absolute value inequalities. So in a previous video we talked about absolute value equations and how to solve them, and we also talked about why solving them makes sense. It's because, for example, if we have the absolute value of x plus 2 is equal to 6, we need this inside expression to be 6 units away from the origin. We need it to either be positive 6 on the inside of this absolute value or negative 6. And if we were to use a number line, both of those distances are exactly 6 from the origin. Negative 6 is exactly the same distance from the origin as 6 is. And that's the distance we're looking for. But now we're going to be looking at absolute value inequalities. So let's say we have something like x minus 3, absolute value of x minus 3, is greater than 10. So if we have something like this, the idea and the way we solve this inequality would actually change. It's not the same as solving the equation, and let me show you why. If we were to write our number line out like this, so that's actually, for just to be really simple with it, let's say absolute value of x for now. So if we just have absolute value of x is greater than 10, then we need our answer, we need x, to be 10 units away from the origin or more. So let's say this is 0 right here. This is the origin, the center of the number line. And we need our answer to either be greater than 10. This makes sense, just logically, because we need it to be 10 units away from the origin or more. So that's going to be greater than 10. Or it's going to be less than negative 10, because everything in this direction is also more than 10 units away from the origin. And here we would use open dots right on 10. Open dot it just means that we don't have an answer at negative 10 or 10, but it's just it's left out of the solution set. So everything past negative 10 in the negative direction, everything past 10 in the positive direction will be part of our solution set here. This makes sense, again, because we need a solution set that is farther than 10 from the origin. So say we had something like this instead. That's for the greater than case. Let's say we had something like absolute value of x is less than 4. So this slightly changes. Instead of being greater than, it's less than. So what that means is our solution set is all of the numbers that are less than 4 units away from the origin. So here's the origin, here's 0 on the number line, and then here's negative 4, and here's 4. So if we wanted something that's less than 4 units away, we would take everything between negative 4 and 4. Everything past 4 in the positive direction is too far away, it's not less than 4, and everything past negative 4 is more than 4 units away from the origin as well. So we need this inside area. And you see how whenever we have a greater than sign, we kind of get those arrows pointing outwards from each other. And when we have a less than sign, we kind of have this solution set that is between 2 points. So however you want to think about that, if you want to remember that in a different way, that's fine, but just know that the reason behind this is because the greater than, you need a distance away from the solution. You need a solution set that's a distance away from the origin or greater, so it goes outwards. And for a less than sign, you need a distance away from the origin or less, so that's going to be between the 2 points. So let's practice solving some of these equations. You notice that when we've done this, when we've been solving these, what's been happening is something like this. If we just had absolute value of x is less than 4. And what we really found is, by using our number line, we found that the solution was x is less than 4. We found all the numbers between x is less than 4, but x also had to be greater than negative 4. Between these two inequalities was our solution set. So we would write an AND because it needs to satisfy, our solution set needs to satisfy both of these inequalities. So we'd write an AND. For our greater than, we had absolute value of x is greater than 10. And our solution set here was the numbers that are where x is greater than 10, or the numbers where x is less than negative 10. You notice that we only had to satisfy one of these inequalities in order for our answer to work. So in this case, we'd write an OR. And this is actually always the case. You can think about this as greater, because if you have a greater than sign, it would always be OR. And less than, you can think of less than. But that's just a mnemonic so you can memorize it. So let's try a more complicated equation than that. What if we have something like x plus 5 absolute value is greater than 10? Something like this. So for example, just from what we already did, we already know that our answer is going to involve two inequalities and an OR. So we have to satisfy at least one of the inequalities, or either or the inequalities, in order to get our solution set. So let's solve this one. It's going to be x plus 5 is greater than 10, just like in the last problems. And the other problems as well, we flipped the inequality sign and we added a negative on, because we either need to be greater than 10 we either need to be larger than positive 10, so we're 10 units away from the origin, or less than negative 10, also 10 units away from the origin. So we're going to be x plus 5 is less than negative 10. Now we solve these two inequalities just like how we would solve them normally. So x is greater than 5 in this case, and x is less than negative 15 in this case. And the way we would write these answers out, there's two different ways. You could write it as what's called set notation, which we've learned about before. It would essentially look like this. We'd say negative infinity to negative 15, and we union with 5 to infinity. That would be one way of writing our solution set. And another way, if you were told to write on a number line, you would just write how we did in the earlier problem, negative 15, here's 5, open circle, because our solution set does not include negative 15 or 5, because it's greater than and not greater than or equal to. And you would draw arrows pointing outwards. If this were greater than or equal to, by the way, the only difference in this question would be that these circles would be filled in. And in our set notation, we would write brackets instead of parentheses. So that was a greater than example. Let's now try a less than. Remember, in our less than, we needed an and with our inequalities. We needed to satisfy both of them in order to be part of our solution set. So let's see. If we have 3 times the absolute value of x minus 5 over 2 is equal to, let's say, 42, or not equal to, sorry, less than or equal to 42. So we have a less than, so we need to satisfy both inequalities. So let's try and solve this. Remember, we want to isolate the absolute value. It's the same thing as the previous equations where we wanted to isolate the absolute value. So let's do that here. So we're going to divide, actually we're going to multiply both sides by 2/3 just to get rid of this fraction right away. The 2/3 cancel on the left, and the 2/3 on the right side, let's see, the 3 you'd cancel with the 42, and that's going to be 1 and 14. And 14 times 2 is 28, so it's going to be absolute value of x minus 5 is less than or equal to 28. And let's do exactly what we've been doing. Take the absolute value bars off. We need this to either be less than or equal to 28, or x minus 5 needs to be greater than or equal to negative 28. So let's solve this just by adding 5. So it's going to be x is less than or equal to 33, and we have x is greater than or equal to, and we have negative 23. And remember, we need an and here. We need to satisfy both of these inequalities. So the way we would represent this in set notation, since we have less than or equal to and greater than or equal to, we're going to use brackets, and it's going to be, our solution set's going to be between negative 23 and 33, because we need to be less than or equal to negative or to 33 and greater than or equal to negative 23. And representing this on a number line, you can simply draw out the numbers like this. Here's negative 28. Here's, or sorry, negative 23. And here's 33. And our solution set's going to be all points in between them with closed circles because we have equal to. So that would be our solution set. And so that's how you would solve absolute value inequalities. And I'll see you in the next video.